Kurwa. Let me explain. A month ago, I built my first drone ever in a week. On its first flight, it climbed at 0 throttle and crashed twice. And I ended that video genuinely not knowing why. So I pulled the black box logs off it. Nothing on this drone was broken. It was lying to itself.
You can try me if you want, but the last one died and got put on a shirt. I've been in the game 7 years, but I was hot, so it's all a blur. Damn right, I'm getting a lot, but I still ain't getting what I deserve.
The answer was not what I expected. Every drone has a gyro, it's the inner ear. It tells the flight controller that it's rotating. Mine is obviously directly on the AIO, and it's supposed to be on 4 little rubber grommets. So it feels the drone, not the frame. When I built it, I tightened these 4 screws slightly too hard, which almost squashed the rubber flat. So the gyro wasn't isolated from anything. It was bolted rigidly into a printed frame that turned out to be very good at vibrating. Once I crossed a certain amount of power, the frame started vibrating at around 140 Hz. And the gyro couldn't tell between real movement and vibration, so the flight controller tried to correct a movement that was never happening. Correcting means spinning the motors harder. Spinning harder creates more vibration, and more vibration leads to more fake movement. It was fighting itself, and it was winning. Which finally answers the question I ended the last video on. Why didn't it stop when I dropped the throttle? Because 0 throttle doesn't mean motors off. It means I'm not asking for any more climb. The controller was still stabilizing, and by stabilizing, it was holding all of the motors at around 40% throttle. And on this lightweight build, it meant ascending. The only thing that actually stops the motors is disarming, and that's exactly what I did, but 5 stories up. So the fix was mostly mechanical and embarrassingly simple. I remounted the board so the grommets could actually do their job. Not crushed, just tight enough to hold it in place. Then I reinforced the frame, so there's less for the gyro to feel in the first place. And additionally, I softened the tune, dropped the PID strength to 70%, added more filtering, and told it to watch for 3 different vibration frequencies. So part of what crashed my drone was over tightening 4 screws. I'm gonna be thinking about this one for a while. But if I was rebuilding it anyway, I wasn't just going to print the same parts again. So I almost completely redesigned the main frame. Alright, I'm gonna try to make it as quick as possible. So here we've got the V1 that was in the previous video, and here I've got the upgraded version 2. So V1 had a couple issues that I spotted after the crash. First of all, we had a crack here, and it kind of makes sense as this is extremely thin. And to fix that, it was quite straightforward, just making the whole thing thicker. Also, adding these fillets helps a lot. The second issue was quite a bit more difficult to troubleshoot, and it was this break along the layer lines. The thing is that when the drone falls, it usually hits the ground with just one arm. And when the force is upward, here we've got this very long lever, so you really don't even need that much force to just break it off, because it really holds on just this and this. And to fix it, I first heavily reinforced this part, as you can see. Secondly, I made the connection between the 2 connectors even more seamless. As you can tell, it now looks much more natural. And as the third fix, I added this. This is very important because this absorbs the forces that usually broke this part. There were also some other minor changes, like changing the pattern in the middle, but they are not that important. It's a lot more heavy duty, and I think it just looks better as well. And as a nice little coincidence, it turns out that with the new frame, the whole drone weighs exactly 100 grams. And then, finally, the boring part. It just hovers. That's it. That's the whole thing it couldn't do a month ago. And it's really fun. It's precise, it's dynamic, and after everything, it just works. Which brings me to the part that will probably surprise most of you, because there's a number I never properly explained. So here it is. This drone weighs 145 grams, and those motors will happily produce over a kilogram of thrust. That thrust to weight ratio is about 8 to 1. Reference a fighter jet's, it's 1-to-1. So I decided to find out what it could really do. And to push this build to the limit, I changed two things. First, the props. Up till now, I have been flying on these. Smooth, efficient, easy to fly, great props to learn on. These went on instead. Same size, number of blades, and basically the same weight. What changed is the pitch. Pitch is how far a prop tries to screw itself forward every time it goes around. These went from 2 inches to 3. So every single rotation, they take a 50% bigger bite of air, and they're wider, which makes the motors work much harder. But it was kind of the point. And then, second thing, step by step, I was taking the power limiter off, and obviously ended up with no limit at all. And this is where it gets interesting.
Zero volts.
O kurwa! Oh yeah. I'm still trying to find a camera angle that will finally portray just how diabolical this is, but it's quite hard. I hope this will do the trick, you know? Alright, now a slightly longer one. I wonder how long will we wait for the drone to come back down, but yeah. That's just... isn't that crazy? So I pulled the flight log, and I'm going to present you some very interesting numbers. For context, a rocket launching astronauts into orbit peaks at around 3 to 4 Gs. This is a 145-gram printed drone. One honesty note, it has no speedometer. So the speed is reconstructed from the barometer and gyro readings, but it's cross-checked across multiple launches, and the slowest one still came at 0.7 seconds. During that session, I launched it 34 times across 3 different batteries. It didn't flinch once. It's not all free, by the way. The aggressive props pull way more current. They are harder on the battery, and hovering got much trickier because now the hover point is in the bottom 5% of the stick. It's a worse drone to just fly around. It's a much better drone to just launch into the sky. Last video, I asked you whether building a drone in a week was a success or a failure, because I really couldn't decide. Almost nobody actually answered that. You just told me the video was cool, which I appreciate, but that's not what I asked. So I guess I'll answer it myself. It failed. Properly. Twice. I found out why, fixed it, and ended up with a 145-gram drone that hits 8 Gs and does 0 to 100 in 6/10 of a second. That's not a failure that got rescued. That's just what building something really looks like. First drone I've ever made. I'm keeping this one.